Okay, guys. Data management U3A1 and A2. So let me see what I can get going here. So first of all, U3A1, we look at scatter plots. Okay, so looking at that here. What's important here? We're looking at two variable stats now. Okay, so we're looking at a relationship between two different things. Most of the time, what you'll have is time as one of the things you're looking at. So variables you're looking at, sorry. So before we had things, one variable stat, you might have something like this. What's your favorite ice cream? You say chocolate, vanilla, strawberry. Okay, let's leave it at that. And then you have the number of people who like it, and then you make a graph that looks something like this. And you're measuring one thing. Okay, you're measuring how many people like this type of ice cream. Okay, but now what you're going to do is you're going to have usually time on the bottom here, and then something else here. So a lot of times it's velocity. You might find height, dollars, like stock market, the value of a price of something. Okay, you throw something in the air and it lands. You might have a distance time graph. You might have a height distance graph. Okay, you might have a velocity time graph and all that sort of thing. Okay, so you're measuring two things here. So the last one had dates here, and then you had what was the topic? I can't remember. Percentage of women who worked in the workforce. Okay, percentage of women in Canadian workforce over time. So what you have in this case a little bit different. You have years here, and then you have percent here. And what you've been asked to do is do a scatter plot. Okay, so put the points like this, and then what you're going to do is see if you can make a line or a relationship out of this sort of thing. Now, the line of best fit is important for linear relationships. So that will lead us to our next part, U3A2, which is talking about the correlation stats. So what you're looking at is you have a bunch of points, a bunch of dots, okay? And they're not connected, so be careful. You cannot connect them, because if you have 1955 here, 1956 here, and you connect these, what you're saying is that if I wanted to find out in the year halfway between 1955 and 1956, that there's a value that can be read off this line. Now that's not necessarily true, okay? So don't connect the dots. It's not one of those graphs, okay? And you put the dots like this, and then you ask yourself, is there a relationship? Does it look like there's some sort of relationship? And then that's where we get to the strength of relationships. In general, okay, if something goes like this, it's a positive relationship. So think of your linear learnings from grade 9, okay, positive slope. So if you take a line of best fit, now talking about line of best fit, it says go through as many points as possible. I've seen other ways to describe it. In general, you ask yourself, look, is this line here, okay, I have 1, 2, 3, 4 dots above, 4 dots below. Does it go through a lot of points? That's one way to look at it. Another way to describe a line of best fit, a good line of best fit, is to minimize the overall distance between the points and the line. Okay, so if you measure these distances, and not on a positive or negative value, but just the actual length of them, you'd want to minimize those. Okay, but in general, what you want to do is draw a line of best fit that represents the points in question. Now, there are curves of best fit. Some things are not linear. Okay, so if you have something that does this, bunch of points, you might go, okay, that might be quadratic. And there are things that aren't linear, are not quadratic, and there are other things. Okay, but in general, right now, what we're looking at is, are there straight lines? And by lines, I mean straight lines of best fit. And a line of best fit that's drawn like this is positive. A line of best fit that goes this way is negative. Okay, so what that means is you have a positive relationship between this thing and this thing. So if this is time and this is population of something, that would mean that as time increases, so does population. Okay, and if this was time and this was population, and we had a line of best fit that went down this way, that would mean that over time you have a decrease in population. That's what a negative correlation means. Okay, as one increases, as your independent goes up, your dependent goes down. Okay, and you have a negative slope to the line of best fit. Okay, so it's not a positive or negative as far as good or bad. It's just, is it a positive slope